Now student, we are going to solve question number 4.13, and in this question actually we have two parts, part number A and part number B. Clear? So in part number A, question is given to you: a circular coil of 30 tons and radius 8 centimeter carrying a current of 6 ampere is suspended vertically in a uniform magnetic field of magnitude 1 Tesla. Okay. The field line makes an angle 60 degree with normal to the coil. Clear? It means we can say angle between magnetic field and the area vector. This is 60 degree. Clear? So now concentrate. First of all, I am writing here all the parameters that is given to you. So in this question we can see we have number of tons. This one is 30. Clear? We have number of tons 30. Clear? Radius is given to you, r equal to 8 centimeter. Clear? It is carrying a current of 6 ampere. So I can say current is given to you 6 ampere. It is suspended vertically in a uniform horizontal magnetic field having value of B. This is 1 Tesla. Okay, fine. Field lines make an angle 60 degree with the normal. It means I can say angle between theta, or we can say angle between area vector and we can say magnetic field. This is given by 60 degree. Clear? Now in this question it is given to you, calculate the magnitude of counter torque that must be applied to prevent the coil from turning. It means definitely we can say whenever there is an angle between area vector and the magnetic field, we find a torque will act on that we can say circular coil. Clear? So when the torque will act, definitely we can say torque is given by one formula. This is beta sine of theta. Clear? Torque is given by beta sine theta. Clear? Now we can say actually this torque is acting on this circular coil and this torque will try to rotate that coil, but we have to find the value of counter torque so that we can place that coil in a stable position. It means I can say counter torque is also having same in magnitude but direction is opposite. Clear? So I can say value is given by beta sine theta. Beta means B means we can say 1, I we can say this is 6, number of turns we have 30, area vector. Now important part, area vector, because this is a circular coil, I can say area is given by pi r square. So pi value of r is given 8 into 10 to the power minus 2 whole square and multiply. I can say this value of sine, so I can say this is sine 60. Clear everyone? So this is equal to 6 into 30 into pi into 8 into 8 into 10 to the power minus 4 into we can say this is under root 3 by 2. Clear? So I can say this is value that is 4. Clear? First we simplify all the thing. 6 into I can say this is 30 into pi into 8 into 4 into under root 3 into 10 to the power minus 4. Clear everyone? Now listen carefully. Now we have to just solve and we will get our answer, value of torque. Clear? So now we can say value of torque, this is given by, I can say this is 180 multiply I can say 22 by 7. Clear? Here we have 32. Clear? And we have here root 3. So I can say 1.73 or into 10 to the power minus 4. Clear? So how can we calculate? We can say here we have almost 5, or we can write almost, we can say this is value approximate I am taking 3. Clear? Value of pi I am taking approximately 3. Clear? So I can say this is 540 into 32 into 1.73, or you can write like this 173 into 10 to the power minus 6. Clear? So now first you can multiply 540 with 32. Clear? Or you can multiply with 173 with 540. So we can write like this, first I am multiplying 540 with 32. So you can multiply just 54 with 32. How can we multiply? We can say this is 8, we can say this is 10 and 12, that is 22, and we can say this is 15. So 8, 2, 7, 1. Clear? So I can say 1728. Clear? So this value we have 17280 and multiply 173 into 10 to the power minus 6. Clear? Value you will get in Newton meter because this is a torque. Clear everyone? Yes. So Now just multiply. Approximately you can say, okay, just multiply, better it will be 17280 and this is 173. So I can say I am just multiplying with this one. Clear? You can say we have here 4, we have 2, we can say 8, this is 1, we have 2 left, this one 5. Clear? We have 6, we have 5, 14, we have 19, again we have 1, this is 50, we have 5, so we can say 12. Clear? And if we multiply it with 1, we can say 8, 2, 7, 1. Clear everyone? So from here we can write this is 4, we can say 8, 4, this is 8 or 6, we can say this is 14, we have 1, so 2, 9, 11 and we can say 20, we have 2, 7, 2, 9, we can say this is 9 and this is 2. Clear? So from here you can say we are getting value 299044. Clear? And this is multiplied with 10 to the power minus 6 Newton meter. Clear? So now you can say 1, 2, 3, 4, 5, 6. Clear? It means we will get here value of counter torque, this is 0.299044 Newton meter. Clear? So if you simplify it, you can say, because we are taking here approximate, so we can say correct answer will be approximately 0.3 Newton meter. Clear everyone? So like this you can solve. Definitely calculation is lengthy because this is related to NCERT. So you can actually solve this question very easily if you do some calculation like this. Clear everyone? You can take some approximation also. So approximately you will get here value of torque, this is 0.3 Newton meter. Clear everyone? So this is all about this question.